Good evening or afternoon, depending on what coast you're joining us from, and welcome to MitoAction's Roundtable discussion with Dr. Melanie Gillingham. Tonight, Dr. Gillingham will share with us all about ketones. My name is Stephanie Harry. I'm a parent of a teen with LCHAD and one of the patient support coordinators here at MitoAction, and I will be your host for this evening. Tonight's discussion will be recorded and available on the MitoAction website in the coming days. The space is a little different than our traditional expert series. We set this call up as a Zoom meeting, which means that you have both video and audio access. We encourage you to turn your videos on if you would like, but please keep yourself muted during the presentation, as this will give everyone the most pleasurable experience. If you have questions throughout the presentation, please put them in the chat and I will ask them at the end of today's presentation. Or if you would prefer, you may raise your virtual hand after the presentation and I will call on you. So without further ado, let me officially introduce Dr. Melanie Gillingham. Dr. Melanie Gillingham is a professor in molecular and medical genetics at Oregon Health and Science University in Portland, Oregon. She completed her PhD in nutrition science at the University of Wisconsin-Madison and a postdoctoral fellowship in genetics at OHSU. As a metabolic dietitian, she has been investigating nutrition interventions in patients with fatty acid oxidation disorders for 25 years, which is absolutely amazing. And so this is a shorter version of bio that she gave me. So I wouldn't, go on and on and on, but I could go on and on and on because we all love Melanie and appreciate her hard work and dedication to our community. So thank you so much, Melanie, for being here tonight, for giving us an update, for sharing with us about ketones, educating us, and we're really looking forward to this presentation.
Well, thank you, Stephanie. That was very nice. And thanks for keeping it short. I do know many of you on the call, so it's nice to see everybody. This is going to be much more educational. So I'm going to sort of try to tell you a little bit more about ketones, about why we're talking about ketones, tell you about things we know, and then a lot of things that we don't know. And hopefully this will kind of shed some light just on the whole aspect of ketones and why this keeps coming up. So it really is just, it's gonna be a little bit more of an educational kind of presentation. And I am going to see if I can advance my slides here. There we go. All right. And we'll keep a laser pointer here. All right. So what are ketones? We're going to do a lot of chemistry today. So I'm showing you the chemical structure of beta hydroxybutyrate, which is one of the main ketones. And the other ketone is acetoacetate. And acetone also counts, but this is the chemical structure. So it's got an oxygen and these are carbon units and some hydrogens. And basically, ketones are another source of energy. We can use beta hydroxybutyrate and acetoacetate, and we can convert it to ATP, make energy from it. So that's one of the things that we should know about ketones, is they are a source of energy. So how are ketones made endogenously? How do we make them inside our bodies? This is why this becomes such a topic for patients and families who are experiencing fatty acid oxidation disorders. The way we make ketones is that fats in our liver go through fatty acid oxidation to make acetyl-CoA, and then that acetyl-CoA from fat oxidation is used to make beta hydroxybutyrate. That beta hydroxybutyrate leaves the liver and goes into your blood system, and then it can travel through your blood throughout your whole body and become an energy source for the brain, for the heart, for your skeletal muscle. So we make ketones in our livers endogenously through fat oxidation. As you can imagine, if you don't have fatty acid oxidation in the liver, you can't make ketones. So those two are linked together. You have to have fat oxidation in the liver to be able to make ketones endogenously. So when do we make ketones? So one of the times that people without a fatty acid oxidation disorder make ketones is during fasting. So I'm showing you a curve here. This is time, hours on this x-axis down here, and this is plasma concentrations of various substrates. So our glucose after a meal might start a little bit higher, and then as we fast, it kind of comes down, but then it stays at a fasting level because your liver's keeping your glucose right in that normal fasting level, hopefully. Your insulin might be high after a meal, and then as it drops, you start mobilizing fatty acids from adipose tissue. They go to your liver. Your liver is doing fatty acid oxidation, and that's when you see this rising ketones. So insulin is low and your ketones come up. So when you're fasting, a normal individual makes ketones. This doesn't happen in patients with fatty acid oxidation disorders, right? So when you're fasting, you don't make ketones. You're still doing all these other things. Insulin's dropping and you're mobilizing fatty acids, but you don't make ketones in this situation because of the block in fatty acid oxidation in the liver. Let's see if we can keep going here. Yeah. So when else do we make ketones? The other time we make ketones is during moderate intensity exercise. So if you're going to go out and exercise in a really high intensity, like sprints or something, this is a high intensity in here, that uses a lot of glucose. It doesn't use a lot of fat, but it uses a lot of glucose. And so you can make your lactate go up. But this here is the ketones don't go up for that. But if you go out for a moderate, long walk or cycling or running where you're doing a long exercise for a long period of time, that is a time when we make ketones. So normally your muscles would use those fats and you would end up making some ketones, and you can see ketones rise in moderate intensity exercise. So in normal physiology, we make ketones during fasting and we make ketones during moderate intensity exercise. And in both of those conditions, that doesn't happen in someone who has a fatty acid oxidation disorder. Another time you might hear about in sort of society is some people are trying to become ketogenic or use ketones for energy by eating a ketogenic diet. So a ketogenic diet, I'm sure everyone on this call is aware, you cut carbs, you eat lots of fat and protein, some low carb vegetables. So you can raise your ketones by eating this way. So if you're eating fat and not carbs, you can increase your blood ketones. Let me just be really clear. This is a very bad idea for anyone with a fatty acid oxidation disorder. This is not a way to make ketones for sure, but this is how other people might be trying to make ketones. As you know, we're not going to advocate a high fat diet and restricting carbs. You need those carbs. So this is not a way that we're going to spend any time talking about. I'm just letting you know that is a way some people raise their blood ketones. So we've covered so far is their ketones are this alternative energy, and we make them in our liver through fat oxidation. And then the end product of fat oxidation becomes ketones that we release into our bloodstream, and then they travel to other tissues to be used for energy. So people with fatty acid oxidation disorders, and that's all fatty acid oxidation disorders, are hypoketotic or have low blood ketones. They don't make as much ketones as someone without a disorder. And that includes the long chains, MADD or GA2, medium chain, all of them. There's lower ketones. Lower ketones with fasting, lower ketones with exercise. You just have lower ketones. So ketones, you can think of them as sort of an end product of fat oxidation, and that's missing. So people with fat oxidation disorders are hypoketotic, have low ketones. So that brings us to the idea that if we can't make them endogenously, maybe we could take them exogenously as a supplement. We could consume them and replace them in a patient with a fat oxidation disorder. So that's what's been sort of floating around the field for a while now. Actually, a lot of people have been considering ketones as an alternative supplement that we could use for treating patients with fat oxidation disorders. And this is a figure from a review paper that just lists the different types of supplements that are out there on the market. So for long chain defects, MCT is kind of a supplement for ketones. You can take MCT, which is, a medium chain fat, and it'll go to the liver. And in patients with VLCAD or CPT2 or LCHAD, you can take that MCT and you can make ketones out of it, and your ketones will rise. And I've done lots of studies where if you give oral MCT, you'll see ketones go up afterwards. So that's one idea. Does not work for MCAD. But for other fat oxidations, one idea would be to take supplemental MCT would raise your ketones. Another product, this 1,3-butanediol, is a ketone alcohol on a backbone. So it's been proposed as a potential ketone supplement. The most common that you've probably heard the most about is beta hydroxybutyrate salts, so ketone salts. So you take a ketone and it's attached to a sodium or to some other salt, and it's a powder, and you mix it with water. It tastes really salty, and you drink it. So it's a ketone salt. And this one has been probably the most studied, and in the most studies is the ketone salt type of form. So we'll talk about some studies in patients with fat oxidation disorders that have used this product. And then the last potential supplement that's relatively new on the market is a ketone ester. So that takes a ketone and it binds it to a glycerol backbone. So there's 3 ketones on a glycerol backbone. So it looks like a triglyceride, but instead of a fatty acid on the glycerol, it's a ketone. So we have a couple different ways we could do supplemental ketones. And again, the concept is if you can't make the ketones endogenously, why don't we use the ketones as a supplement to provide that what would normally be there if you had an intact fatty acid oxidation system in your liver, for instance. So those are the different types of supplements, supplemental ketones. And now we get to do a little bit more chemistry. I think this is going to be confusing. I hope not, but it's a little bit hard to understand. But if everybody takes up their hands, right and left, okay, we're going to organic chemistry. Our bodies are so smart. So we have our hands. We have 2 forms of ketones. We have a right hand and a left hand form, and they're called enantiomers of each other, or optical isomers. So they look exactly the same, except for that one's a right and one's a left. And it's a 3D shape that it's hard to kind of describe, that it looks just a little bit different. So we have D, which is your right, and L, which is your left. D and L forms of beta hydroxybutyrate, a DL. Okay, so I was talking to someone about how do you explain, enantiomers and isomers, and my lab research assistant said, well, think about it like your headphones. You've got a right and a left headphone. And if you put the left one in your right ear, it feels weird, right? It's funny. So it's the same concept. You have a right and a left beta hydroxybutyrate. So the DL beta hydroxybutyrate means that there's the right and the left both in there. And I'm hopefully going to tell you why I think this is important, but this is a big problem in our current understanding of ketones, is this right and left isomers. So it's the exact same molecule. It's the same carbons, the same oxygens, the same everything, except for it has this 3D structure that's slightly different. So beta hydroxybutyrate comes as a D, which is your right, or a L, which is your left, but they're 2 different, slightly different isomers. So why does that matter? Well, let's talk about, if we go back to the beginning of what I was saying, when our liver makes beta hydroxybutyrate from the products of fat oxidation, it only makes D. That's what's made endogenously. Enzymes in our body are so specific that they only make the right-handed side form. L does not exist from an endogenous synthesis. However, when you go to the lab and you try to make ketones, the lab doesn't, the chemistry in the test tube isn't as specific as the enzymes in our body. And so what happens is you get a mix. In the lab, you get 50% D and 50% L because it doesn't understand the isomer right hand, left hand when you're making it in a test tube in the lab. So if we buy a commercial product, a salt, it contains both D, the right hand, and L, the left hand, beta hydroxybutyrate. It's a mix. So when we have that mix, that DL mixture, we call that a racemic mixture, and it contains both enantiomers, so the right and the left. There are a few products that only have the D. So the ketone ester data that I'm going to show you is from a product called Delta G. I don't know if you've seen it. You can buy it online. It is only D beta hydroxybutyrate on that glycerol backbone. And then I'll tell you a little bit about a salt product that we used at OHSU from Nestle Health Science. It's also only D. But most of the studies, 90% of the studies that have been done on ketone supplementation include this racemic mix. So it's got a mix of both D and L. So this is the problem. We know D is the endogenous form, but the commercially available product is this mix of right and left. Doing that. So why do we care? Does it matter? If we take a mix of right and left beta hydroxybutyrate or D and L, does it have an impact? I'm going to walk you through some data from this particular paper. It's done by some researchers you probably will recognize their names. Dr. Dirks from Groningen, Ron Wanders in the Netherlands, in Amsterdam. So a lot of these people are really well known in the field, and they were looking at this D versus L question, particularly for GA2 or multiple acyl-CoA dehydrogenase deficiency, or MADD. So let's just look at what they looked at. So this is one of the figures from their paper, and they measured, they got the mixed salt. So this is the DL sodium beta hydroxybutyrate, and they gave it to 2 patients with MADD. So panel A and B is one patient, and panel C and D is another patient. And they measured how much the total ketones went up in their blood over time. And then they measured the difference, the L and the D. So when we look at this, let's look at graph A here, and I hope you can see my pointer. The blue is all the total ketones. So it goes up at about 30 minutes, and then it starts coming back down about 3 hours, 880 minutes, because this is time. The pink is the L form. So that's the left-handed beta hydroxybutyrate, and it mirrors that. It goes way up and it stays up. And the green is the D form, and it doesn't go up as much, and it goes back down faster. So it's a little bit lower. And the black is just the acetoacetate. So the actual ketone beta hydroxybutyrate gets degraded to acetoacetate. So that's the black. The B one is just looking at it on a log scale. It's the same data. So I'm really going to kind of focus on these A and C panels. So in the second patient, same thing. They gave them the DL mixed ketone, and the total ketones went way up, and the L was higher. In this patient, it peaked at about 60 minutes. So between 30 and 60 minutes, it got to its peak after taking this salt beverage. And the D was quite a bit lower, but by 3 hours, it was coming back to normal, to baseline. So that's what they saw, is that the L was higher in blood than D in these 2 patients. And that it goes up fast, 30 to 60 minutes after taking it, and then it's back down to baseline in 3 to 4 hours at the most. So it's a fast up and a fast down when you're taking ketone salts. They don't stay around for long periods of time. So then they also took rats, and they wanted to see the same thing in a rat model. So they fed rats just the salt without the ketones. That's this panel A, and nothing happened. Well, that's good. That's the control. It's just the salt. And then they fed rats the DL mix salt again. And again, you can see that in the rats, the blue line is the total ketones go way up. The L goes super high and stays up. And in the rats, it wasn't even coming back down till almost 5-6 hours after they gave it to them. And the D is way down here, so kind of lower. So even in the rats, the L isoform, the L entameter was really high and the D was kind of low. But again, it goes up pretty quick and then it ultimately comes back down and returns to baseline. So why do we care? Does it matter whether the L's high or D's high in blood? Well, what matters is what gets into the tissue. What matters is what gets into the heart or gets into the brain or into the muscle so that the muscle can use it or the heart could use it for energy. So with rats, they were able to take the tissues and measure how much of those ketones got into the tissue. So this figure shows you, so you've got the D form and the L form on our x-axis here. The open circles are just the 0 time point, and then the gray circles are after a load of the salts, the ketone salts. So let's just start looking at the brain tissue. So in the brain, there's a little bit increase in the D form, but a pretty substantial, I mean, I'd call that a good rise in L. So L seems to get into the brain more than D, which that was a surprise to me. Here's the heart, and the heart takes up ketones really well. Both D and L are pretty high here. So the heart can use the D and the L, takes it up pretty quick. In the liver, it goes up a little bit in both. And then in the muscle, also a little bit up in D, but more substantially up with L. So it looks like the tissue concentrations in the rats, the L goes highest in the brain and the muscle, and the D goes high in the heart, is what they concluded. So what does high blood L beta hydroxybutyrate mean? What is that? Does it do anything? So we don't know. That's one of the big problems, is we don't know what L beta hydroxybutyrate does. So the authors of this paper, who again are prominent physicians in this field, have a couple of ideas that they suggest in the discussion of what's happening here. They suggest that having high L in your bloodstream probably means that your tissues aren't taking it up as fast. So the D doesn't go up as high or stay up as high because your tissues are actively taking it up and using it. They're used to seeing D because that's the normal endogenous beta hydroxybutyrate. They're not used to seeing L. So maybe there's less removal from the bloodstream, and that's why it stays up in blood. They suggest, again, it's their hypothesis, that this L form is really not used for energy, but it's used to make cholesterol, and maybe it helps with cholesterol and fat synthesis in the brain, which you do need lots of cholesterol for your brain. They also suggest the D is what's used for energy. You don't really make energy from the L, but from the D. And I'll show you more data that that's probably true, especially in the heart. The heart really loves to use ketones. So the D form is probably being used in the heart. And the L, maybe, potentially the L has some benefits for some brain symptoms that some patients with MADD suffer from, like leukodystrophy. It's possible, but that was all sort of their hypotheses in the end of this paper. We don't have solid evidence that all this is true. This is what the researchers are proposing. So that's sort of the comparison between the D and the L in MADD. So what about just in healthy control people? Has anybody compared the D-L mix versus just D alone in normal healthy individuals? And so I'm going to show you just a little bit of data from this paper. This was actually the scientist that I worked with from the Nestle Health Science, Dr. Chenard, and he looked at the mix versus just the D salt by itself in this paper. So just to kind of tell you what they did is they recruited some healthy volunteers, and all of the healthy volunteers consumed 3 different meals. They consumed a meal containing MCT to raise their ketones. They consumed a meal with a DL beta hydroxybutyrate mix, so both isoforms. And then they consumed a meal with just D beta hydroxybutyrate salt. So these were the 3 meals. And they're looking to see what's happening in their blood after these 3 different meals. So this is the main results of the table. So time, again, is our x-axis. So this is hours, 1, 2, 3, 4. And then on our y-axis, we've got plasma ketones here in A, plasma D, beta hydroxybutyrate in B. And the red line is the D only salt. The blue line that's kind of buried under here is the MCT, and the orange is the mix. So in their healthy subjects, the D made the ketones go way higher than either MCT or the mix by them, the DL mix. And that was true for the total plasma ketones and for the D beta hydroxybutyrate. And this is acetoacetate. So in their hands on healthy volunteers, the D only sent the blood ketones higher than the mix or MCT. They measured the L form, and luckily it only went up when they gave L, which makes sense, right? It shouldn't go up if you only gave D, and the D, it didn't budge down here. So this is a little bit different than our previous study that showed that the L was higher, but they seem to think that the D only actually gets your ketone levels in your blood a little bit higher. So then the other thing they did, which was super cool, is they used a tracer. They gave a tracer to a healthy volunteer, and this tracer, when you're in a PET imager, lights up pink. And so they did the tracer of the D salt, and they said, what tissues does it go to and get used for energy? So this is a picture of a patient in a PET scanner, and this bright pink spot is their heart. So they took this tracer orally, and then they, a little bit later, about a half an hour later, put him in the scanner, and you can actively see the ketones are going to his heart and are being used for energy in their heart and their kidneys. The kidneys are not quite as bright. They're these little pink things down here, but they were able to actually physically see that these ketones were being taken up by the kidneys and the heart and used for energy, which I thought was pretty cool to be able to do that. Okay, so let's talk about the data that's in patients with MADD, so GA2 or multiple acyl-CoA dehydrogenase deficiency. This is probably one of the better papers that kind of gathered the experience of physicians kind of across the world, and it put together sort of a retrospective look at their experience with the DL, so the mix sodium beta hydroxybutyrate, because this is what's been available. We haven't had a just D. This is what's commercially available. So in this study, they had 16 patients that had a clinical improvement while they were taking beta hydroxybutyrate, 3 that they were not sure if it was improvement, and 4 that did not have any improvement while on this ketone therapy. So what improved among these patients that were taking this DL sodium beta hydroxybutyrate? So one thing is that everybody that had cardiomyopathy and they measured the cardiomyopathy after the treatment, they all got better. So their hearts all got better with the DL mix. So it definitely seems to improve cardiomyopathy. Many of them, 4 patients with 1 not improving, questionable improvement of the leukodystrophy, the brain symptoms that come with MADD. Most had improvement with liver symptoms. So their liver function tests were better. Many had improvement with muscle symptoms. There were 2 that had no clinical improvement and 2 that were not sure about. And then it sort of drops off. The respiratory failure, 4 got better, 1, no clinical improvement. There was no change in neuropathy, and it wasn't necessarily preventative if they didn't already have clinical symptoms. So it really seems to the beta hydroxybutyrate seems to be more clinically efficacious for cardiomyopathy, the leukodystrophy, liver, muscle symptoms. So what were the downsides, the bad sides? Some patients did pass away. Now, MADD is a severe disease, and so you could argue this was going to happen, be part of their disease anyway. We don't know. There were some abdominal pains, a prolonged hospital stay. The main thing, if you look at these adverse events, is GI. I've tasted them. They're really salty, and so drinking this big salty load, some people had constipation, dehydration, diarrhea. I mean, it was GI symptoms predominantly were the adverse effects of taking this therapy. So what about other fatty acid oxidation disorders? Many of you may be aware of this paper. This was a paper that came out of the Netherlands group, and they used that ketone ester. So this is D only. It doesn't contain the DL mix. It's just D, and it's only patients with VLCAD. So they had 5 patients with VLCAD, and these patients with VLCAD came in and they exercised on a bicycle. And they did it twice. It was a crossover design. So they did it once with a carbohydrate beverage before they exercised, and then once with a ketone ester, the delta G, plus a carbohydrate beverage. So every patient did both, and they, some of them did the carbohydrate first and then the ketone ester. Some did the ketone ester first and then the carbohydrate. It was randomized. And then they were looking to see if the ketone ester provided a beneficial effect during exercise. So first, I'll just start with the adverse thing. The adverse events were definitely GI, nausea, vomiting. A couple of people threw up when they took the ketone esters. They don't taste very good. I did buy some just because I wanted to taste them. And they call it blueberry flavor, but it's not. It doesn't taste very good. So some people didn't tolerate it very well. But other than that, everybody got through the protocol just fine. The ketone esters did not impact the CK levels. So the CK levels, the red is going to be the ketones and the blue is the carbohydrate by itself. And there's no difference in the ketones. They were able to exercise the same. So they really pushed them to, work hard during this exercise, and they did great. Their heart rates were about the same with the ketone esters versus the carbohydrate alone. The respiratory exchange ratio, so that's telling you, are you burning carbohydrate? If the higher it is, you're burning more carbohydrate, the lower you're burning something else. So they did see that with the ketone ester, it lowered they're burning the ketones. This is what this is telling us, is that they're burning the ketones while they're exercising. So that's good. Here's their beta hydroxybutyrate levels in their blood. So you can see that the ketone ester really raised their beta hydroxybutyrate. It's way high compared to the carbohydrate down here. So it worked. There was lots of ketones in their blood. Their glucose was a little bit lower, but within normal range. Their lactate was a little bit lower, and lactate's what make your muscles sore. So you might feel a little less sore after ketones. And then one of the things they noticed is that really suppressed the acylcarnitine. So they had lower C14-1 acylcarnitine, and then they had lower 14, 16, and 18 acylcarnitine. So it suppressed those acylcarnitines. And it did that because it suppressed free fatty acid release from your adipose tissue. So there was just lower free fatty acids after the ketone ester drink. And the authors argued that the acetylcarnitine, which is your energy source, was higher. So they think it provided extra energy, although it's a bit of a subjective measure, but I mean, not a little hard to argue that, but that's what they're arguing, that this shows better energy production. So overall, it was pretty well tolerated. It certainly suppressed acylcarnitines. It raised the hydroxybutyrate, and the patients exercised similarly across these two treatments. So carbohydrate alone or carbohydrate with a ketone ester beverage. I know there's a lot of data. We're getting close here to the end. The last one I'm going to tell you about is one that's hot off the press. We just published this. So this is our D beta hydroxybutyrate salt. So this is just the D, it doesn't contain the L. And we had 5 patients who tried this product compared to dextrose. And this is the product from Nestle Health Science. Again, it's a crossover design. And we were looking to see if this D beta hydroxybutyrate salt would improve exercise in patients with fatty acid oxidation disorder. There were 2 patients with CPT2, 2 patients with LCHAD, and 1 patient with VLCAD in this study. And I'll just give you the punchline. I'm not going to show you too much data. When the patients consumed the ketone salt, it did suppress free fatty acids. So it suppressed that lipolysis from the adipose tissue. And the acylcarnitines were substantially lower. So it really lowered the acylcarnitines in blood. When they consumed the glucose, you got free fatty acid rise and a rise in acylcarnitines like you would expect. So the biggest thing that we saw was that suppression of acylcarnitines. It was a pretty small dose of ketones, and I don't think that the participants could tell that they felt better or it was easier to exercise. So to me, the effects were more biochemical and maybe not as dramatic as we'd like to see for a treatment. So I think, we're considering, do we increase the dose? Do you do multiple doses? We're looking at other ways that you could use ketones to sort of fuel activity or fuel energy for patients with fatty acid oxidation disorders. So what do we know about ketones? What we know is that the D, the right-handed form of beta hydroxybutyrate, is endogenously synthesized. We know that D beta hydroxybutyrate is used for energy. It's actively taken up by muscle and heart, especially the heart, and used to make energy when it doesn't have glucose, when it's fasting or exercising. We know that D beta hydroxybutyrate suppresses release of fatty acids from adipose tissue, and it lowers acylcarnitines. I've showed you 2 studies where it does that. I also showed you a study where L goes high in blood and stays in blood after a mix, a DL racemic mix. We don't think that you use L form for much energy. It doesn't really produce a lot of energy. And we know it gets to the brain based on that rat data. It looks like the L gets to the brain. Well, we don't know. We don't know, does L have any other benefits? Right now, we're just speculating. We don't know, is it particularly helpful for the brain? Should we focus on just a D isoform? Should we just do D beta hydroxybutyrate, or is there an advantage of a DL mix? We don't know the answer to that question. And so forming a grant or a hypothesis or designing a clinical trial with this, I feel like these are important questions we need to address so that we can do a good job of writing a study that would be beneficial for patients and of interest to funders, that we could potentially get funders. So I think there's some important questions we don't know about the DL mix that are hindering us kind of going forward with what's the next step. So there's a big push for people looking at ketones, not just in our rare disease world, but in athletes and in others in general. There's this belief, this idea out there that ketones improve your vascular function, lower oxidative stress, improve mitochondrial function, decrease inflammation. We think that they're helpful for blood pressure. They dilate vessels. There's some people who think that they're good for, maintaining body weight. It certainly improves heart function. So all these functions have been linked to ketones. I will say most of them have been linked to the D beta hydroxybutyrate, the endogenous form, not the DL mix, but there's a lot of interest. So I think there's a lot of science going on about ketones, not necessarily just in the FAO world, but there are still some questions that we have not answered. We don't know. So I think I finished with plenty of time for questions. That's my last slide. I'm going to stop sharing. I realized it was a lot of educational stuff. I hope it was informative to try to give you a landscape of what's going on in ketone research. And I hope I can address anybody's questions if you have any.
Yeah, so there's definitely some that have been put in the chat, and I'll start with those. But if you have questions that you'd like to ask yourself, feel free to raise your hand and I can call on you. I'm curious with the last slide that you showed, and you said that there are lots of there's lots of research going on about this right now, but it's more the hydrogenous form. Is that what you're saying? Not because you said it was more the D form in and of itself, but not the DNL, but there's a lot of DNL product out there. So, like, is it because they're studying it and its effects already inside of people, or are they
I
just
think
using the D form?
no, some of the studies that I've seen are using are looking at in fact effects like with a ketogenic diet in a healthy population, or doing other ways to raise ketones, but endogenously inducing ketone synthesis. So that was why it would be the D form. You're right. Most of the products on the market are this DL mix. So I think there's interest in other ways of raising ketones. That aren't going to be applicable in our particular situation. You know, ketogenic diet's off the table here. That's not something that we're going to consider. But there are some research studies going on that are looking at it from a different angle.
So someone asked in the chat, they said for someone with VLCAD taking MCT or Dojolvi, what do you think would be the benefit of ketones potentially?
That's a great question, and I think I honestly don't know. I think that's an unknown question. But I think the thought, at least in scientists' minds, are if you look at Bernard's study, that the ketones will actually get your ketones a little bit higher. There might be a little bit less GI distress if you're really struggling with some of the burning or some of the other problems with MCT. Ketones might be a little bit better tolerated. And it's closer to that energy source than the MCT. So there are potentially some benefits, but that is still an unknown at this point. I don't know that we've proven that it's more effective than MCT or C7. That study hasn't been done.
And in the study that you did in your lab with it, were the patients were they still on their MCT or their Dojolvi and they also did the ketones, or did they have to get off of their oil supplement?
So I'll just make the caveat for our study. It was very acute. It was very short. So they came in, they spent the night, ate their diet the same. The next morning, we fed them a breakfast that did not contain any MCT or C7. And then a couple hours later, they took the ketones and exercised. So they didn't have it in their system at the time of the exercise. It was from the day before, but we didn't ask them to stop it except for the day of the exercise trial.
That small window. Okay.
Yeah, so it's a very acute. We didn't do a long-term study. We haven't done, longer treatment. It was just a very short window of time.
And from a study standpoint, could you create a study that a patient stays on the supplements that they're already on and you add to versus having them to quit everything that they're on and just try the that particular supplement?
You could. I think that would be hard to interpret that data. And then, yeah, so it would be hard to say what's happening if you're mixing multiple supplements. So just from a trial design, that might be challenging. I would have to really think about what would be the best trial design from that standpoint.
So another patient asked, was there any, okay, so these questions kind of go together. One patient asked, patients with MADD have issues with retinopathy? And if so, was any of that when they were looking at the studies, was that tracked at all with the eyes and the hydroxybutyrate?
I don't recall that study looked at eyes at all. So I think the answer is no. So I'm not sure I know that answer to that question, if there's ever been ketones that have specifically looked at eyes. There is some recent data suggesting that the retinal pigment epithelium in your eye does make ketones. And in our hands, when we've done LCHAD, retinal pigment epithelium, and dish, they don't make ketones. So there is a ketone link. but whether it's causative or just a side effect, that's also not really known either. So a lot of unknowns on the eyes and ketones.
The product that Nestle is trying that is just the D form, that is just internally, right? Like that's not anything that's on the market because I think you've said several times the DNL is what is on the market. So if patients are on
So,
here, yeah.
right, the product that Nestle was working on, and I haven't talked to them in a while, so I don't know where they are in developing it. It has not gotten to the market yet. There is the ketone esters are on the market. So I did find Delta G on the web and you could buy it. It's expensive, but I was curious. So I just bought it so I could taste it and see what it was like. But that one is the D only in an ester form. So that is available, but the Nestle product that we tried is not yet. I think they're still planning their next study and what they're going to do.
And how did the ester form taste?
I thought the ester form did not taste good at all. I tasted the Nestle product and it to me tasted like a salty Gatorade. It was pretty mild and very easy to tolerate. The ester part, I bought a little blueberry thing and it comes like a 5-hour energy shot. It was not terribly tasty in my opinion. So maybe someone else has tried it and they like it. I don't know, but I did not like it.
So, okay, so here's kind of along the same lines. So if there are patients out there that are starting to try ketones on their own, because we know there's supplements and stuff out there, what are things that they should really talk to their dietitian about if they're exploring that on their own? Like what are like some red flags that should be like, hey, make sure that you talk to your dietitian about like if it's a salt ester, right? You can get too much salt, right? Like or what are some of those items?
Yeah, so people have been worried about the salt load. And that definitely is is a problem with the salts. We did try it in a mouse study and the mice will just quit drinking because it's too salty. So you got to watch for dehydration and messing up your electrolytes. So I do think letting your medical team know that you're going to try it is good so that if if you decide, yeah, I'm feeling really lethargic or I'm really thirsty or something like that, they'll know to kind of look for electrolytes. That being said, a lot of patients with MADD have taken it for years and years and years and have not had problems with electrolytes. So I think the risk of electrolyte abnormalities is pretty low. It's not zero, but it has not been a real problem for patients who've taken really high doses for extended periods of time.
Another patient asked, is there any downside to including the L? If potential benefit and little downside, would it be best to start with a DL?
So the downside from the scientists' standpoints that have been kind of batting this concept back and forth is that you only have so much volume. And if you're trying to provide energy and only 50% of it provides energy, why not just make 100% of it the energy? If that's really your goal is to fuel the heart or to give, to replace the energy you would otherwise have in normal ketone synthesis, the L doesn't do that. Why not just do all the D and provide more energy if that's the goal? So that's why I think that question about does the L do anything is something that we need to find out because yeah, to me, it does make sense. If D is the only one providing energy and that's our goal, then we should provide the D. If the L has some other benefit, then yeah, maybe a racemic mix is more advantageous. But at this point, we just don't know what the L does.
And it seems like it would be good too to know what the L does because things have they can be good and bad. So if you don't know like what something is doing and you're just putting it in your body just because it exists in there, like it seems beneficial to kind of know what things are doing before you put it in your body. It's late at night. I'm not explaining exactly how I'm trying to.
No, I understand.
But I just think of like, how sometimes it seems like, something that is benign might have a bad effect on somebody's, body. So like it seems like it can have like maybe a long-term effect. So I think it's a worthwhile question that scientists are asking, is what I'm trying to say.
Yeah.
Um, so this is an interesting question too. So I think she said, not sure if this is relevant for other disorders, but certainly to VLCAD. Is there any evidence suggesting reduction and rhabdo with using ketones? And I think you touched base on that a little bit in your slideshow, but can you just talk about that again?
So, to really answer that question, I think we need a different study design. Does it improve exercise? Yes. But that's in a lab conditions. And for those of you that have participated in studies like that, it's really different walking on a treadmill in a lab when you're hooked up to all these different things versus your regular life when you might go into rhabdo. And we've never done like a long-term study where, this group of patients is on ketone esters and these ones, or ketones and these ones aren't, and does this group have lower rhabdo? And that's really kind of what would have to happen to say, yes, it lowers the incidence of rhabdo. Does it improve exercise? Yes, we can say that in a lab situation. Does it have the impact in the real world that we hope? We haven't done that study to really prove that. So right now we're basing it on these lab studies that are short and controlled, and we maybe need that longitudinal study where people are living their real lives and we're collecting
Mhm.
data, how often they get,
So I don't
in the
know. Can you
hospital.
hear me?
Yes.
Yeah.
Hello. Hi. I'm the one that asked that question. It's Candace Helm. I'm from Canada.
Uh-huh.
Um, but my son struggles like obviously with rhabdo. So yeah, the only reason I asked was if it could be used to maybe get someone out of rhabdo, I guess is the better way I should have phrased it, in times of like hospitalization and things like that. Um,
Right.
where like it doesn't seem like anything's working or there's no amount of IV fluids that can
No amount of
kind of help.
glucose or anything like
Yes.
that that's turning around. Yeah. No,
Yes, that could be interesting.
yes, it could. And that actually is an interesting idea because of its unique suppression of lipolysis and acylcarnitines, it could be beneficial. I can see how it could be helpful. No one's ever done that. I mean, to
Hmm.
my knowledge, I don't know of anybody that's tried it, but I can see how IV fluids with glucose and perhaps some ketones could reverse that catabolism and move you into anabolism so that you start feeling better faster. It's possible. But
Yeah, and I've mentioned it with obviously our metabolics team, but obviously nobody's tried it.
no, nobody
So
that I know, nobody's
when
tried
you're
it.
in that desperation, it's always something you think about,
What can
right?
I try? Right. Yeah.
Yes.
Yeah.
Thank you.
Yeah.
I think, and Candace, I think that's a really good question too, when you're thinking about, like you mentioned, cardiomyopathy and the reversal of cardiomyopathy. And I'm curious if the studies that you looked at go any deeper than that, if they look at long QT and or not about any reversal of those items either.
The study in genetics and medicine and the patients with MADD, it was a little more broad. They were just talking about, it didn't get into real specifics. However, I know there's a ton of interest in ketones and and cardiomyopathy. Specifically, there's a lot of interest in heart failure with preserved ejection fraction. They call it HFpEF instead of reduced ejection fraction. And I know, and this is just on the general population side, not in the FAO world. But there is evidence that, so SGLT2s, which are this diabetic drug, is actually improving hearts. And they think that it does it through ketones, is one of the hypotheses, that it works by raising your ketones and that improves your heart. In our mouse study, in the LCHAD mouse, when we fed them ketones, it was a DL mix. The one thing that did really, really dramatically improve was the cardiomyopathy. So their hearts were normal size after the DL, after long-term beta hydroxy salts versus the ones that just got the salt without the ketone. So I do think there's evidence that ketones are impacting cardiac function for sure.
Which is super exciting because I think there are a number of people in our community that have been on the oils and are still having issues with the cardiomyopathy component. So it'll be interesting. Dr. Chatfield's supposed to come in next month and talk about heart-related stuff. So we'll have to throw in the ketone question to her.
Good.
as
Yeah.
well.
Yeah.
Um, so another patient asks, has anyone looked at if L-isomer would change in uptake over time with a longer term use?
Like if someone was chronically on the DL mix, does the isomer removal go faster? Not that I'm aware of. That paper that I presented that actually you had sent me, Stephanie, but I had seen before, it just did those two patients. They were chronically on it and the L was higher in their blood compared to D. So I don't know that anybody's done it at baseline and then, after 3 months or after 12 months, I don't know of any data to suggest that it changes over time, but I also don't know that we've measured it.
Another patient asks, are patients mixing ketones with Dojolvi or MCT currently? Do you know of any clinicians that are trying that?
Not that I'm aware of. You guys probably know better than I do if that's happening. So not that I know of, no.
Yeah, I would say I've not heard of that, but it doesn't mean like talk to your clinician about it. Always talk to your clinician before you try new things it's a good rule of thumb. But it's definitely, but ask. I mean, I am that mother for my child where I bring in my boatload of questions that I ask because even if clinicians don't have answers in the moment, it gets them thinking outside of the box. It gets them asking the questions and harassing lovely scientists like Dr. Gillingham. Okay. Had all of these questions. So I think it's always good to ask. Um, Another patient asked, is there a readily available preprint version of your recent paper on
On the ketones.
mhm.
So I was going to before this call, but I will email the PDF to you, Stephanie, and you can post it wherever you want. You have we'll just make sure that you have a copy of all the ones that I talked about tonight so that people could read them if they wanted to. So yeah,
It's
I will make sure
amazing.
make sure
Thank
it's
you.
available. And if you want to, you're welcome to dive in and read them.
Absolutely, absolutely. So I will talk maybe either I will A, get it out to you guys via email, the people that showed up, or B, maybe I could talk to Melanie and see if we're allowed to post it right underneath the expert series, and so people can go there and have a clickable link. So we'll make sure those logistics are legit.
Right.
Okay, so there's a couple more questions, and let's see. Okay. One patient shared that they've been on keto canna that has both um, D and L for ketones, and it's reversed their child's cardiomyopathy, but they don't say what condition their child has. So, another patient said, are there any follow-up studies anticipated in the future or are being discussed right now?
So, yes, the Nestle group is talking about some follow-up studies with multiple dosings during the day, keeping ketones higher for longer term, not just one acute dose. So they are thinking about that. And then I also know that there's some people working on basic science questions too. So maybe answering some of our L questions in cells in vitro. So giving cells both D and L, or giving them just the L, or giving them just the D, and looking to see what happens in their metabolism. So I know there's a group that's trying to look at it on a basic science side too, to try to answer some of this unknown about the L isoform.
I think this is really, really helpful because I think you did a really good job at sharing the research that exists, sharing where the research is going, but also what it takes in order to get a product even out to our community. It's not as simple as let's just try this and go for it. Like you have to understand how it's being used, how it's functioning in the body, and then work with how does it actually look in patients? How does it look in rats? Patients aren't rats. And yet, like there's a lot to wrap your mind around and to process. And so We really appreciate you and all of your hard work and asking the hard questions and sharing the science with our community and breaking it down because it is a lot to understand, but you did it in such a wonderful way. And I'm really
Thank you.
excited to be able to share this with others in our community as well.
Well, thank you. I appreciate it. I hope it was helpful.
It was great. So thanks everybody for coming tonight. This again is recorded and will be posted in the next week or so on our website, and I'll connect with Melanie about the options of the journal articles and stuff like that, and trying to make sure everybody gets those appropriate links. So stay tuned and look out for an email from us. And next month, Dr. Chatfield will be here and talk about the long chain FAODs and issues with the heart and cardiomyopathy. So hope you'll join us then, and have a wonderful evening or afternoon.
Thank you.
Bye.